Now here we have the fourth point is, here we have this L, vector L is equal to, या स्केलर फॉर्म में लिखते हैं कि एंगुलर मोमेंटम इज गिवन बाय दिस इज mvr sin theta, right? So when it will be minimum, you write different cases. L will be minimum when sin theta will be minimum, when this sin theta will be minimum. And what is minimum value of sin theta? It is equal to 0. Minimum value of sin theta will be 0. So when mod of sin theta will be equal to 0 or minimum, we can say that theta is 0 or 180 degree. Here we have theta will be equal to 0 degree or 180 degree. That is, arm vector is parallel to velocity vector or parallel or anti-parallel to the velocity vector. So we can say that this angular momentum is minimum if vector r and v are parallel or anti-parallel. Parallel or anti-parallel. Right? Second, now we are, if the point is on the line of motion, angular momentum is minimum and 0. Or we can say that if the point where we are angular momentum is desired is on the line of motion, angular momentum is minimum and 0. AM is minimum and it is equal to 0, right? So this is the case 1. Now come to case B. What will be maximum value? Now here we can write this L is will be maximum corresponding to sin theta will be maximum. And what is the maximum value of sin theta? It is equal to 1. So L max, maximum value of angular momentum will be equal to mv into r, that is, here theta will be equal to 90 degree. So if a body is rotating in a circular path of radius r, and this is the velocity with velocity v, in this case the angular momentum is maximum and it is equal to mv into r, right? Similarly, that is, in case of circular motion of a particle, angular momentum is maximum and it is equal to mv r, right? So these are the cases. It is minimum and maximum, and it can have any values between 0 and mv r depending on the angle theta.